Welcome to the Deep Dive. Today we're really unpacking a comprehensive roadmap for you. If you're ready to move beyond the basics and step into professional web development, think of this as, well, a clear path laid out, cutting through some of the noise, because web development, as you know, it moves incredibly fast. Staying current feels like a full-time job sometimes. So having a structured approach like the one we're digging into, well, it's really valuable. Gives you focus.
Exactly. And the strength of this roadmap, I think, is how it breaks things down into stages. It takes this huge field and makes it more manageable, building things up step by step. It's not just about memorizing syntax,
Yeah.
It's about understanding the why. Why use this tool? Why this approach? We're drawing from a pretty detailed guide here, and we'll be highlighting those key insights, the essential tools, and, importantly, the professional practices that really make a difference.
Okay, sounds good. Let's get into this roadmap then. Where do we start?
Right, it kicks off with the foundations, the absolute must-haves, HTML, CSS, and JavaScript. The guide is, well, very clear on this. You can't skimp here. It's not just knowing them individually, but how they work together.
And right at the beginning, it stresses something really foundational that kind of shapes everything else. This idea of front end, back end, and full stack. Front end is what you see, what you interact with in the browser, HTML, CSS, JS doing their thing. Back end is, well, all the server-side stuff, the logic, the data, the security. And full stack is having skills in both areas. Understanding this helps you place where technologies fit, how different parts of an application talk to each other. Right, makes sense. So, first pillar, HTML. We know it structures content with tags.
Yeah.
But professionally, what's the key focus beyond just P tags?
Well, beyond the basics like elements and attributes, which you're likely familiar with, it's things like getting the document structure right. .c, type HTML, the HTML tag with the lang attribute, the head and body. These aren't just boilerplate.
Yeah, exactly.
Getting the viewport meta tag with the device width, initial scale 1.0 in there is crucial for responsiveness, right? It tells mobile browsers not to mess things up.
Absolutely. And that ties into a really critical point the guide makes. Semantic HTML. Why bother using article or nav or footer instead of just, div everywhere?
Right.
It's not just about tidiness. It massively improves accessibility for screen readers. And it helps search engines understand your content. Huge for SEO. It's like a core part of professional work, building for everyone. Building meaningful structure, yeah. So using headings correctly, paragraphs, links, lists, these are your tools for that logical organization. And remembering things like the alt attribute on images. Seems small, but huge for accessibility.
It really is.
And forms, of course. Form input. Getting that structure right is key for usability and, down the line, security, too.
The source points to resources like MDN Web Docs, Always Solid, and FreeCodeCamp's responsive web design cert, maybe less for the absolute basics, but good for applying it correctly. W3 School's Try It Yourself feature gets a nod, too, for that hands-on practice.
So the recommended activity here isn't just build a page. It's build a simple static page, maybe a personal profile, a recipe, whatever, but really focus on correct document structure and using semantic HTML properly. Treat it seriously.
Yeah.
Okay, structure's down. How do we style it, make it look good, control layout? That's CSS territory. Cascading style sheets.
Yep. And this is where things get interesting, and honestly, where a lot of people get stuck. The cascade, specificity, and inheritance. The basics, selectors, properties, values. But truly understanding how the browser decides which style wins when rules conflict, that's gold.
Right. Debugging CSS can be painful otherwise.
It really can. Knowing how source order, selector specificity, like an ID beats a class, right? And inheritance work is key. And the box model content, padding, border, margin that's non-negotiable too, understanding box sizing. Border box saves so much confusion.
Definitely. And how you apply CSS matters. External style sheets, link in the head, are the standard, keeping structure and style separate. Inline styles. Generally avoid them in professional settings. For layout, the focus now is really on Flexbox and CSS Grid.
Yeah, forget floats for layout these days.
Flexbox for one-dimension rows or columns. Grid for two dimensions, rows and columns. The roadmap really pushes these modern techniques.
Which leads directly into responsive web design, RWD. You have to build for all screen sizes now, so using flexible units, MREM, percentages, VW, VH, and media queries at media to apply styles conditionally is essential. That viewport meta tag we mentioned earlier is part of this puzzle too.
Right. And then there's styling text, backgrounds, borders. Knowing the nuances like accessibility implications of color choices, that's part of the professional skill set.
For resources, again, MDN is fantastic for CSS. FreeCodeCamp's RWD cert covers Flexbox and Grid well, W3 Schools for quick reference, and CSS Tricks for Well, deeper dives and specific techniques.
Okay, activity time. Take that semantic HTML page and style it up with CSS. Make it responsive using Flexbox or Grid. Really try to make it look polished and work across different device sizes. All right, structure, style, now, behavior. JavaScript, making pages interactive. We know it's the language of the browser, but what's the professional focus?
It's about writing clean, efficient, and maintainable JS. Things like form validation with instant feedback, image sliders, fetching data from servers without reloading the page. That's all JS. You need those core programming concepts, variables, like const mostly now, data types, operators, control flow, ifelse, loops, functions, but applied effectively in the browser context.
And a massive part of that context is the DOM, right?
Yeah.
The document object model.
Exactly. The DOM is how the browser sees your HTML. JavaScript interacts with the DOM API to find elements, change their content, text content, update attributes, set attribute, manage classes, class list, even change styles dynamically. It's the bridge. Mastering selecting elements query selector is super useful, and modifying them is fundamental.
And handling user actions. Clicks, typing, scrolling.
That's events. Advent Listener is your friend here. You attach functions to run when specific events happen. Understanding the event object, maybe stopping default actions with prevent default, that's key for interactive UIs.
Okay, and what about things that take time, like network requests?
Ah, yes. Asynchronous JavaScript. That's crucial. You can't have your whole page freeze while waiting for data. So understanding callbacks, then promises, and especially the modern async await syntax is essential for non-blocking operations. And you'll be working a lot with JSON, parsing it, json.parse, and creating it, json.stringify.
And handling potential problems.
Good error handling using try.catch is vital for robust code. Don't just hope for the best.
Resources.
MDN's JavaScript guide is indispensable. Free Codecamp's JS certs cover a lot, including algorithms and DOM stuff, W3 Schools for quick examples, and JavaScript.info is often recommended for really in-depth explanations.
Right, so the activity is add some interactivity to your style page using JavaScript. Maybe a button that shows shide something or basic form validation. Get comfortable changing the page with code, so that covers the big three. HTML, CSS, JavaScript. The roadmap really emphasizes taking your time here, focusing on deep understanding. Rushing this part apparently leads to trouble later.
Absolutely. Solid foundations make everything else easier.
Okay, foundations are set. What's next on the roadmap? Looks like essential developer tools and practices, stuff beyond just writing the code itself.
Yeah, exactly. This is about working efficiently, collaborating, and managing projects like a pro. These tools aren't optional in most professional environments. They help you manage complexity and work effectively in a team.
First up, version control with Git. And platforms like GitHub, GitLab, Bitbucket. We know version control tracks changes over time. Git is distributed, so everyone has the history.
And why Git is indispensable. It's your safety net. Undo mistakes, try out ideas on branches without risk. But more than that, it's the standard for collaboration. You need to speak the language. Repos, commits, branches, merging, these are everyday concepts.
So commands like git init, git add, git commit, SM message, git branch, git checkout, or git switch, git merge, these become routine.
Definitely. Git remote add, git push, git pull for working with remote repositories too.
And the platforms like GitHub.
They build on Git for collaboration. Forking a project, creating pull requests, PRs, or merge requests, MISRs, that process of proposing changes, getting reviews, discussing them, that's central to how teams build software together. Plus, issue tracking for managing tasks and bugs.
Resources. Official Git docs are the ultimate reference, but tutorials from GitHub, Hello World, or the Odin project are great for learning the workflow. Okay, activity. Put your HTML, CSS, JS project into a Git repository on GitHub. Practice the workflow. Create a branch, make some changes, commit them with good messages, push the branch. Bonus points if you can pair up with someone and practice the pull request process. Next tool, the command line interface, or CLI, the terminal.
Why bother with the CLI when we have graphical tools? Well, often it's faster, more powerful. For things like file operations, running scripts, automation, the CLI shines. Many essential dev tools, Git itself, package managers, build tools, connecting to servers via SSH are primarily command line based. Getting comfortable here is a huge efficiency boost.
So basic navigation is key. PWD to see where you are, LTSLs or dare to list files, CD to change directories, UBKey air to make directories, touch or similar to create files, CP or copy, MV or moverin, RM or dill. They vary slightly, but the concepts are the same.
Right.
And maybe even a little shell scripting. to automate simple command sequences.
Yeah, even basic scripting can save you a ton of time on repetitive tasks. MDN has a command line crash course. Codecademy has courses too. Good places to start.
Activity. Try doing all your project file management using only the CLI for a day. Then maybe write a tiny script, perhaps one to set up a standard project folder structure automatically. Third essential tool area, package managers, like NPM or Yarn for the JavaScript world, pip for Python, Composer for PHP. What's their role? They automate installing, updating, and managing the external libraries and dependencies your project uses.
And why are they vital? Because almost any real project uses third-party code. Package managers handle downloading the right versions, ensuring everyone on the team has the same setup. They give you access to this vast ecosystem of open source tools and manage it all through a file like package.json. It saves you from dependency hell.
Focusing on NPM for JavaScript,
Yeah.
you've got the package.json file defining everything. Use npm install to get dependencies, npm install package name to add one, maybe with savedev or justd for tools only used during development like testing libraries, npm update, npm uninstall. These are core commands. Understanding semantic versioning those and symbols helps manage updates safely.
And yeah, pip with requirements.txt for Python, composer with composer.json for PHP. Same fundamental idea, different ecosystem.
Resources are typically the official docs for each manager. Node.js npm pip composer activity. Initialize npm in your project. npm and sy is the quick way. Install a small utility package, maybe something like Lodash or datefns, and actually use it in your JavaScript. Then install a dev dependency like ESLint to see the difference. Okay, foundations, essential tools.check. The roadmap now moves into intermediate front-end development, building more complex, modern UIs.
Yeah, this is where we go beyond static pages and start using tools and techniques designed for larger, more dynamic applications. Think automation, code organization for reuse, handling application state, things that become crucial as projects grow.
First up, CSS preprocessors.
Yeah.
SAS or Ilias mentioned here. So what are these exactly? They're like CSS with superpowers, right? They get compiled down to regular CSS.
Pretty much. They add features that make writing and managing CSS much easier, especially on big projects. Variables for reusable values like colors or fonts, nesting selectors to match your HTML structure, mixins for reusable blocks of styles, partials to split your CSS into smaller, manageable files, even functions and basic math. It's all about DRY. Don't repeat yourself and better organization.
How do you use them? Install a compiler, often via NPM, write your .scss for SAS or .less file, and run a command to generate the .css file.
Yep, that's the basic workflow. The official SAS and LS documentation is the best place to learn the syntax and features.
Activity. Convert the CSS for your project to use SAS. SCSS syntax is common. Use variables for colors, nest your styles where it makes sense, maybe create a simple mix-in for a common pattern like button styling. Next big topic, front-end build tools like Vite or Webpack.
These are crucial for modern development. They automate a whole bunch of tasks, bundling multiple JavaScript files and CSS images into fewer files for faster loading, transpiling modern JavaScript or framework-specific syntax like JSX down to code that older browsers understand using tools like Babel.
Optimization too, right? Like minifying code.
Exactly. Minification removes whitespace and comments. Tree shaking removes unused code. They also usually provide a development server, often with hot module replacement or HMR, so you see changes in the browser instantly without a full page reload. And they help manage assets like images and fonts.
The roadmap highlights Vite and Webpack. What's the difference, really?
Well, Webpack's been around longer. It's incredibly powerful, super configurable, massive plugin ecosystem, but that configuration can be notoriously complex, especially for beginners. Vite is newer, known for being really fast, particularly its dev server, which uses native ES modules. Its configuration is generally simpler out of the box. The source suggests Vite might be a smoother start now, while Webpack offers more power if you need it, but with a steeper learning curve.
Setting up Vite often starts with something like npm create Vite at latest. You get a basic structure, run npm run dev to start the dev server, and npm run build to create optimized files for production.
Right. Resources here are definitely the official docs for Vite or Webpack, plus tutorials showing how to integrate them with your chosen front-end framework.
Activity. Create a new, simple project using Vite. Import a CSS file and a JavaScript module. Run the dev server, make a change, see HMR in action. Then run the build command and look at the optimized output files. Okay, this is a big one. Choosing and learning a front-end framework or library. The advice is pick one to start.
Absolutely critical advice. Frameworks like React, Vue, or Angular provide structure for building complex UIs. They encourage breaking things down into reusable components. They help manage application state, data that changes over time. They handle client-side routing for single-page applications. They basically provide solutions to common problems you'd otherwise have to solve yourself, letting you focus on the unique parts of your app.
Let's quickly run through the main options mentioned. React.
React is technically a library, very popular, component-based, uses JSX, that HTML and JS syntax. Big community, often seen as having a manageable learning curve for its core ideas.
Vue.js.
Vue is a progressive framework. You can use it for small parts or a whole SPA. Known for great documentation and a gentle learning curve, often uses HTML-like templates but supports JSX too.
And Angular.
Angular is a full platform, more opinionated, from Google. Uses TypeScript, has a steeper learning curve but offers a very structured approach with lots of built-in tools, often favored for large enterprise applications.
The source seems to lean toward React or Vue as starting points for beginners, mainly due to the learning curve and community support. But the key takeaway is, commit to one. Learn it well. Don't try to learn all three superficially.
Exactly. You need depth in one. Core concepts you'll encounter regardless are components and passing data via props, state management, routing, lifecycle methods or hooks, running code at specific points, and, crucially, fetching data from APIs. The official documentation for whichever framework you choose is paramount. It's usually the best, most up-to-date source. Then MDN guides, free code camp certs, and maybe paid courses on platforms like Scrimba, Udemy, or Coursera if you like structured video learning.
Activity. This is a bigger one. Rebuild your project or start something new like a to-do list or a basic e-commerce product display using the framework you picked. Focus on components, props, and basic state. Still in this intermediate phase. Working with APIs. Fetching and displaying data. So APIs are how our front end talks to back-end services, right? Usually exchanging data using JSON.
Yep. On the client side, you'll typically use the browser's built-in fetch API or maybe a library like Axios, which adds some convenient features. You send an HTTP request, like get to fetch data, to an API endpoint.
And the API sends back JSON.
Usually, yes. Your JavaScript then needs to parse that JSON string, json.parse, into an object you can work with. Then, in your framework, you typically update the component state with this fetched data, causing the UI to re-render and display it.
And it's important to handle loading states, right? Show the user something is happening, and error states if the API call fails.
Absolutely. Good UX demands that. Show a loading indicator. Handle errors gracefully. Don't just leave the user hanging or show a broken page.
Resources for this.
MDN docs on Fetch are great. Tutorials specific to making API calls within your chosen framework are essential. And there are tons of free public APIs you can practice with, like JSON placeholder for dummy data or the Poke API for Pokemon info.
Activity. Find a public API and integrate it into your framework project. Fetch some data, display it dynamically, and make sure you implement loading and error handling states.
Okay, wow, that covers a lot of ground on the front-end side. Now the roadmap shifts gears towards the back-end, the server-side stuff.
Right. So the front end handles the user interface, but the back end is where the core logic, data management, and security often live, especially for dynamic applications with user accounts or persistent data. Even if you aim to be a front-end specialist, understanding back-end basics is vital for collaboration. So, key concepts first. The client-server model browser, client, requests info from the server. The request-response cycle, that whole communication flow. Server-side logic code running on the server, processing requests. And data persistence, storing data long-term, usually in a database.
Exactly. Those are the fundamentals.
Then comes a big choice, picking a back-end language and framework.
Right.
The source lists a few common stacks.
Let's break them down briefly. Node.js with Express.js JavaScript on the server. If you're comfortable with JS from the front end, this is a natural transition. Good for applications with lots of I/O.
Makes sense.
Python with Django or Flask. Python's known for readability. Django is batteries included, full-featured, great for building complex apps quickly. Flask is a micro-framework, more flexible, often used for APIs or smaller projects.
Okay.
Ruby with Ruby on Rails, famous for convention over configuration, which can really speed up development once you learn the conventions. Java with Spring Boot, very common in the enterprise world. Robust, scalable. PHP with Laravel. Modern PHP framework, elegant syntax, lots of features, very popular in the web world.
How do you choose? The source mentions factors like your existing language skills, project needs, ecosystem, job market.
Yeah, for beginners coming from JS, Node Express is often recommended. Python Flask or Python Django are also popular starting points due to Python's ease of learning. The key again is to pick one stack and dive deep initially. You can always learn others later.
And where does the data actually get stored? Databases.
Right. It's essential for any app that needs to remember information. Two main categories are discussed: SQL, relational, and NoSQL, non-relational.
SQL databases, like PostgreSQL or MySQL, use structured tables with rows and columns. You define relationships using keys. You interact using SQL commands: select, insert, update, delete.
Very structured.
NoSQL databases are more flexible. MongoDB is highlighted as a common document database, storing data in JSON-like documents within collections, often good for scalability and less rigid data structures.
And here's a concept that makes working with databases much nicer, especially for beginners: ORMs and ODMs. Object relational mappers for SQL, object document mappers for NoSQL.
What do they do?
They let you interact with the database using your programming language's objects and methods instead of writing raw SQL or database-specific queries. Think user.save instead of crafting an insert into users.statement. It abstracts away a lot of the database details, boosts productivity, and can help prevent certain types of errors like SQL injection if used correctly. Examples are Mongoose for Node MongoDB, Squalchemy for Python SQL, Django's built-in ORM Rails Active Record.
Got it. So they bridge the gap between your code and the database.
Precisely.
Okay, so you have your backend language, framework, database. Now you need to build the API endpoints for the front end to talk to.
Yeah, building backend APIs, often using the RESTful architectural style.
RESTful. What are the key ideas there?
It's a set of principles for designing networked applications. Things like statelessness: the server doesn't hold client session state between requests. Using standard HTTP methods for CRO operations: get to retrieve, post to create, put to update, delete to remove. Using resource-based URLs like API users or API products 123. And using standard HTTP status codes to indicate success or failure. 200, okay, 404, not found, etc. It creates a predictable interface.
The source also mentions GraphQL as an alternative.
Right. GraphQL is a query language for APIs. Its main benefit is allowing the client to request exactly the data it needs in a single request, which can be more efficient than REST in complex scenarios, avoiding fetching too much or too little data. It's gaining traction, but REST is still very common, and you'll need tools like Postman or Insomnia to test the APIs you build, regardless of style.
Resources: MDN, DEV.2 for REST concepts. Framework tutorials usually cover building basic APIs. Specific GraphQL tutorials if you go that route. Activity: using your chosen backend stack, build a simple RESTful API. Create endpoints for basic CR'd operations, maybe managing a list of tasks or users. Then, modify your front-end application to fetch data from this backend API instead of the public one. One last piece for the backend section: basic authentication and authorization. Auth-in and Auth-Z.
Super important. Auth-in is verifying identity. Are you who you say you are? Usually login. Auth-Z is determining permissions. Okay, you're logged in, but are you allowed to do the specific action?
What are common ways to handle this?
Session-based auth is common for traditional web apps. Server creates a session, stores info, gives the client a cookie with a session ID. Token-based auth, often using JWTs, JSON Web Tokens, is popular for SBAs and APIs. Server issues a token, client sends it with requests, server verifies it. It's stateless on the server side. OAuth 2.0 is more about delegated authorization. Think login with Google.
And a crucial point: password storage.
Absolutely critical. Never store passwords in plain text, ever. You must use strong hashing algorithms like bcrypt or Argon2. Salt them properly, too. This is non-negotiable security practice.
Okay. Resources often come from security blogs or identity platform docs.
Right.
Activity: implement basic user registration and log in on your backend. Maybe use JWTs for token-based auth. Then, protect one or more of your API routes so that only logged-in users can access them.
Yeah.
So now we have a front end talking to a back end with data storage and basic security. The roadmap now shifts towards those practices that really mark you out as a professional developer, ensuring the app is secure, reliable, ready for the real world.
Exactly. This is about moving from "it works on my machine" to building robust, maintainable, and deployable applications. It covers security in more depth, testing, getting your app online, and automating workflows.
Let's start with web security basics. We touched on password hashing, but what else?
It's about protecting user data and the application itself. Understanding common threats is key. The OWASP Top 10 list is a standard reference for the most critical risks. You need to be aware of things like injection attacks, specifically cross-site scripting, XSS, and SQL injection.
XSS is injecting malicious scripts into pages other users see, right? And SQL's messing with database queries.
Precisely. Mitigations involve sanitizing user input and escaping output for XSS, and using parameterized queries or ORMs for SQL. Another big one is CSRF cross-site request forgery, tricking a logged-in user into making unintended requests. Anti-CSRF tokens are a common defense, and using HTTPS Everywhere's fundamental encrypting data between the client and server prevents eavesdropping and builds user trust. Browsers flag non-HTTPS sites now anyway.
Resources, MDN Web Security, OWASP Palace site, Cloudflare's Learning Center are good starting points. Activity, go back through your application. Look for places where user input is displayed or used in queries. Are you validating input? Escaping output. Ensure your deployment, even if local for now, can run over HTTPS, maybe with a self-signed certificate for practice. Next up, software testing principles. Why is testing so important?
It builds confidence. Confidence that your code works, that new changes haven't broken old features, regressions, and that the overall quality is high. You test so you can deploy without crossing your fingers.
What kinds of tests are there?
The main types are unit tests, which test small, isolated pieces of code like individual functions or components. Integration tests, which check how different parts work together, like does your API route correctly interact with the database. And end-to-end E2E tests, which simulate a real user's journey through the entire application in a browser.
And use testing frameworks for this.
Yeah, specific to your language stack. For JavaScript, Jest, Mocha, and Cypress, for E2E, are popular. Python has PyTest and Unitest. Java uses JUnit. The key practices are writing code that is testable, sometimes requires thinking about structure differently, and aiming for reasonable test coverage. Some people even practice TDD test-driven development, where you write tests first.
Resources would be the docs for your chosen testing framework, and maybe articles on TDD or BDD, behavior-driven development. Activity, write some unit tests for critical functions or components in your front-end or back-end code. Get a feel for how testing frameworks operate. Maybe try a simple integration test if you're feeling adventurous. Okay, tested code. Now how do we get it online? Hosting and deployment.
Deployment is just the process of making your application accessible to users on the internet. Hosting is where it lives. Options range widely. Shared hosting is cheap, simple, but limited resources, and control okay for static sites maybe. VPS, Virtual Private Server, gives you dedicated resources on shared hardware, more control, better performance.
And then there's a Pale Ale platform as a service.
Right. PaaS providers like Heroku, Netlify, Vercel render abstract away a lot of the server management. You often just push your code with Git, and the platform handles building, deploying, scaling to some extent. They're generally fantastic for beginners and professionals alike because they simplify the deployment process immensely. Free tiers are often generous too.
Compared to IaaS, infrastructure as a service.
Yeah, IaaS is like AWS EC2, Google Compute Engine, Azure VMs. You get raw computing infrastructure, servers, networks, storage, maximum flexibility and control, but you manage everything. Much steeper learning curve, generally overkill for beginners just deploying their first full-stack app. The sorts table comparing these is useful.
So Apache seems like the sweet spot initially, using Git to deploy, setting up environment variables for things like API keys or database URLs in production.
Often, yes, it lets you focus on your code. Resources are the specific docs for your chosen PaaS provider, Heroku, Netlify, etc. They usually have great tutorials.
Activity. Deploy your full-stack application, put the back-end on a service like Heroku or Render, deploy the front-end to Netlify or Vercel, get it live on the internet. And related to deployment, there's CI/CD, continuous integration, continuous delivery, or deployment. What's that about?
It's about automating the process from code commit to production. CI, continuous integration, means developers merge code changes frequently into a central repository, and automated builds and tests run automatically on every merge. CD can mean continuous delivery auditing the release process up to production, maybe requiring a manual click to deploy, or continuous deployment automatically deploying every change that passes all tests straight to production.
Benefits seem obvious. Faster releases, catching errors earlier because tests run constantly, less manual work, more consistent deployments.
Exactly. The core concept is the pipeline, a series of automated steps: fetch code, build, test, deploy. Tools like GitHub Actions, GitLab CI/CD, Jenkins, CircleCI help you define and run these pipelines.
Resources. Lots of blogs and tutorials out there, like from Sem4CI or on dv.to. Activity. Set up a basic CI pipeline for your project using GitHub Actions or GitLab CI/CD. Configure it to automatically run your tests whenever you push code to your repository. Experience that automation. Okay, we've covered an immense amount of technical ground and professional practices. The final section of the roadmap focuses on the ongoing journey, continuous learning and career development.
Yeah, this is crucial. Web development isn't a field where you learn something once and you're set for life. Technology evolves constantly. So staying curious, practicing deliberately, and showcasing your work are key to long-term success. And building a portfolio is how you demonstrate your skills.
Let's talk portfolio. Why is it so important?
It's your proof. It shows potential employers or clients what you can actually build, not just what you say you know. It's often the first thing they look at.
What should go in it?
A variety of projects demonstrating different skills, front-end, back-end, maybe full-stack integration. Projects that solve a problem or show creativity are better than simple tutorial clones. Aim for quality over quantity. Maybe 3-5 really solid projects are better than 10 half-finished ones. Include live demos and links to the code on GitHub. And describe them well. What was the goal? What tech did you use? What challenges did you overcome? What did you learn? Show your process.
And the portfolio site itself needs to be good, right?
Well, absolutely. It's a project in itself. It should be well-designed, responsive, functional. Use it to show off your skills and maybe a bit of your personality.
Resources like career guides can help with presentation.
Definitely.
Activity. Choose your best 3-5 projects. Write detailed case studies for them. Then, build your personal portfolio website to showcase them effectively. The roadmap also stresses effective learning strategies. It's not just about consuming info.
Right. Practice is key. Daily coding helps keep skills sharp. Platforms like LeetCode or Code Wars for algorithms, but also just consistently working on personal projects. Contributing to open source is fantastic experience. You learn collaboration, read real-world code, build your network. Don't be afraid to read other people's code on GitHub. It's a great way to learn patterns.
And learning to read documentation effectively, that's a skill in itself.
It really is. Knowing how to navigate docs, use search, understand the difference between tutorials and reference material, and debugging, that's maybe half of development. Having a systematic approach, understand the problem, reproduce it, isolate the cause. Using browser developer tools, effectively the console, debugger, network tab, techniques like logging, setting breakpoints, even just explaining the problem out loud, the rubber duck debugging method, it all helps.
Sounds like a toolkit for learning and problem solving.
Exactly. Resources abound for coding challenges, debugging tips, and learning strategies.
And staying updated with new technologies. Seems overwhelming.
It can be. But you need a strategy. Follow key people and blogs in the areas that interest you. Subscribe to relevant newsletters, JavaScript Weekly, Front-End Focus, etc. Attend meetups or conferences if you can, even virtual ones. Engage in online communities like Stack Overflow, Reddit, Dev.to. Read official docs for updates to tools you use. And crucially, try things out. Build small projects with new tech to really understand it. Listen to podcasts. It's about continuous, multi-channel learning.
Finally, the roadmap briefly touches on specialization paths.
Yeah, once you've got a solid foundation across the stack, you might find yourself drawn to a particular area. Maybe advanced front-end, working with complex state management, performance optimization, things like PWAs or WebAssembly, or advanced back-end, database optimization, distributed systems, microservices. Or maybe you deepen your full-stack expertise in a specific niche. Other paths include DevOps, CI/CD, cloud automation, cloud architecture, dedicated web security roles, or even mobile web development, React Native, Flutter.
So specialization often comes after getting broad experience.
Typically, yes. It allows you to build deeper expertise, tackle more complex problems, and can often lead to higher paying roles. The source lists some possibilities to think about down the line.
Wow. Okay, we have really navigated a very detailed roadmap here. From those absolute core foundations, HTML, CSS, JavaScript focusing on semantic meaning, accessibility, and interaction.
Through the essential tools that enable professional workflows, Git, the CLI, package managers.
Then diving into intermediate front-end techniques, preprocessors, build tools, choosing and mastering a framework, handling APIs effectively.
Crossing over to the back end, understanding server-side concepts, picking a stack, managing databases with SQL or NoSQL, and using ORMs, ODMs, building APIs, implementing basic security.
And finally, covering those crucial professional practices. Web security awareness, software testing, hosting and deployment strategies like using PANS, leveraging CI/CD automation, and emphasizing that constant learning, portfolio building, and potential specialization are part of the long game.
It's definitely a significant journey outlined here. It has its challenges for sure, but each stage builds real, practical capability.
And it underscores that web development isn't static. That need for adaptability, for continuous learning, it's just part of the job description, isn't it?
It really is. Focusing on understanding the why, practicing consistently, learning from others, engaging with the community, that's how you thrive.
So if you follow a structured path like this, put in the work, stay persistent. Building that rewarding professional future in web development feels, well, achievable. It's right there for you. Go build something amazing.